Antoine Lavoisier was a French chemist born in 1743. He is often called the father of modern chemistry. His work revolutionized the field of chemistry. Lavoisier's most famous contribution is the principle of conservation of mass. Before Lavoisier, chemistry was not very precise. Scientists did not have the tools or the methods to measure substances accurately. Lavoisier changed this with his careful experiments and detailed measurements. He showed that mass is conserved in chemical reactions. Lavoisier's work laid the foundation for modern chemistry. He helped move the field away from alchemy and towards a more scientific approach. His contributions are still essential to chemistry today. In the next section, we will explore his experiments. Lavoisier conducted many experiments. He used precise measurements to study chemical reactions. One of his famous experiments involved heating mercury in a closed vessel. He found that the mass of the mercury and the air inside the vessel remained constant. This experiment showed that mass is neither created nor destroyed in a chemical reaction. Lavoisier realized that the total mass of the substances before and after a reaction was the same. This was a groundbreaking discovery at the time. Lavoisier's careful measurements were key. He used a balance to weigh substances accurately. He also used closed containers to ensure no mass was lost or gained from the surroundings. These methods allowed him to make precise observations. Lavoisier's experiments debunked many old theories. One of these was the phlogiston theory. We will discuss this next. Before Lavoisier, many scientists believed in the phlogiston theory. This theory stated that a fire-like element called phlogiston was released during combustion. It was thought that substances lost phlogiston when they burned. Lavoisier's experiments showed that this theory was incorrect. He found that combustion involves a chemical reaction with oxygen. For example, when a metal burns, it combines with oxygen to form an oxide. This process does not involve the release of phlogiston. Lavoisier demonstrated that the mass of the products of combustion is equal to the mass of the reactants. This finding contradicted the phlogiston theory. It showed that mass is conserved during combustion, not lost. Lavoisier's work on combustion was revolutionary. It marked a significant shift in scientific thinking. The phlogiston theory was eventually discarded. Section 4. Meticulous experimental methods and tools. Lavoisier was known for his meticulous experimental methods. He used carefully designed tools to ensure his measurements were exact. One of his key tools was the balance. Lavoisier also used closed systems in his experiments. This attention to detail was crucial in proving the conservation of mass. Lavoisier's methods set new standards in the field of chemistry. Section 5. Impact on future scientific discoveries. The principle of conservation of mass had a profound impact on science. It became a fundamental concept in chemistry and physics. This principle helped scientists understand chemical reactions better. For example, the conservation of mass is essential in stoichiometry. It allows chemists to predict the amounts of reactants and products. In physics, it laid the groundwork for the law of conservation of energy. The idea of conservation is a cornerstone of modern science. Lavoisier's work continues to inspire scientists today.